Welcome to The Explainer. We're diving into a really fascinating, kind of radical new idea in artificial intelligence today. What if the secret to making AI smarter isn't about building bigger and bigger models, but teaching them to read in a completely new way?
For the longest time, the whole race in AI has been about scale. More data, more power, just more. But now we're looking at an idea that pretty much flips that entire approach on its head.
And this one simple shift, from making an AI read text word by word to letting it just glance at a picture of the text, well, that could change absolutely everything. We're talking from the massive data centers all the way down to the phone that's in your pocket right now.
All right, so let's get right into it. To really get why this shift is such a game changer, we first have to understand a major headache in modern AI. Why is it that a super powerful model starts to struggle, really struggle, when you hand it a 100-page report to read?
It all comes down to this technical term, quadratic scaling. But don't worry, in plain English, it just means that as a document gets longer, the work for the AI gets exponentially harder. So if you double the length, you don't double the work, you quadruple it. This whole thing just spirals out of control, making it incredibly slow and super expensive to process long documents.
Now, you might be thinking, well, why not just have the AI see the document as an image? And people have definitely tried that. But honestly, the old methods were kind of a mess. They created way too much data, they were memory hogs, and they were just painfully slow. It just wasn't a practical solution. Until now, that is.
So if feeding text to an AI word by word is inefficient, and the old way of looking at images was a clunky disaster, what's the solution? Turns out it's a surprisingly elegant one. You just change how the AI reads the picture.
So instead of feeding an AI thousands of little pieces of words, what we call tokens, one by one, optical compression gives it a single, really compact picture of the whole page. It's basically the difference between reading a book out loud, word for agonizing word, versus just glancing at the page and absorbing the content almost instantly. And the difference in efficiency here is just staggering. A single page of a document that might have thousands of text tokens can be represented with as few as 100 vision tokens using this method. That is a massive, massive reduction in the raw data the AI actually has to wrestle with.
So how does this magic actually work? Well, a new model called DeepSeek-OCR makes it a reality with this really clever three-step process. First, an encoder creates a quick visual summary. Then, a compressor shrinks that summary down into something tiny. And finally, a super efficient language model reconstructs the original text from that tiny visual footprint. It's pretty slick.
Okay, but here's the million-dollar question, right? If you compress something that much, do you lose quality? Does all this amazing efficiency come at the cost of accuracy? Well, the data is in, and the answer is a pretty loud and clear no.
This was the central challenge the researchers had to solve. Could a model really, truly reconstruct a complex document from such a tiny, compressed image? And, crucially, could it do it so efficiently that it could actually run on our everyday devices? And the results are just remarkable. Take a look. At a compression ratio of nearly 10 to 1, that means the visual data is 10 times smaller than the text data would be, the model still maintains about 97% precision. That is near perfect performance at a tiny fraction of the computational cost.
And here's how DeepSeek-OCR stacks up against the competition. Just focus on that tokens per page column. Other models need hundreds, sometimes thousands of tokens to do the same job. DeepSeek-OCR, it achieves top-tier performance using just a tiny fraction of that. It's doing way more with way, way less.
And look, this isn't just some cool academic exercise. A breakthrough like this has profound, real-world implications for where and how we use AI in our everyday lives. This is where it gets really exciting.
Because this incredible efficiency, this is the key. This is what could finally move powerful AI out of those giant, power-hungry server farms and put it directly onto our personal devices. Seriously, imagine your phone being able to instantly understand and summarize any document, any chart, any form, without ever needing an internet connection. That's the future this unlocks.
But the implications go even further, into territory that honestly feels like it's straight out of science fiction. Because if you can represent information as a manipulable image, you can start to get really, really creative with it.
What if, by rendering older memories as smaller, blurrier images, an AI could be taught to forget? It could prioritize what just happened, keeping it in high fidelity, while older information fades into a less resource-intensive form, kind of like how our own brains work. This could create an AI that can have a natural conversation,
recalling recent details perfectly while treating older topics as just fuzzy background context. And this completely reframes how we think about building AI. It suggests that the path to more intelligent, more efficient, and more human-like systems might not just be about learning more and more forever. Maybe, just maybe, it also involves the elegant and absolutely essential art of letting go.